A simple method of measuring the speed and the distance between you and an aeroplane is to use the speed of sound as a constant and to find the two measurement. Here is a line in front of me. That line is going from west to east, and the aeroplanes fly here from south to north. So they fly in this direction. So once the aeroplane passes in front of this line, you start measuring the angle at which the sound of the engine will become maximum. For example, the aeroplane passes in front of you, you start counting the angle and the time in seconds. At a certain angle, you are going to hear the sound of the engine very maximum. That is the angle and that is the time, the two variables that you need to measure. The angle at which the aeroplane passing from in front of you to making an angle where the sound is maximum. You measure this angle, you measure the time it took to cover this angle. So you have now right here, here's an aeroplane passing in front of me, right? Here, right here. This is the angle from here where the sound of the engine was maximum, from the line in front of me. This is the line in front of me. You can look at these trailers, the line straight ahead of me. And when it came to these poles, the sound was maximal. How much was this angle? About, say, 15 degrees. You need a protractor to measure the angle, and you need a watch, a stopwatch, to measure the duration in which the aeroplane took this angle. So how do you measure the speed of the aeroplane? You multiply this angle, the sine of the angle. The sine of the angle, not the cosine, by the speed of sound, which is 767 miles per hour in air. That will give you, if you use a calculator to get the sine of 15 degrees, it would be a fraction under, of course, have to be under 1, because the sine of 90 degrees is 1. The sine of 0 degrees is 0. So that angle, the cosine of that angle, the sine of that angle, multiplied by the speed of sound, will give you the distance between you. No, will give you the speed of the aeroplane, because the speed is a vector. There is a vector, the aeroplane is flying in this direction, and the sound is traveling in this direction. So when you have two speeds as vectors, a vector means a variable that has direction and magnitude. When you multiply, when you know one of these vectors, that's the speed of sound, 769, multiplied by the cosine of the angle, by the sine of the angle, it will give you the speed of the aeroplane. How about how far is the aeroplane from you? You multiply the time that you measure the aeroplane takes to cover this angle. Suppose this time is a fraction, 1/3 of a second. You multiply that time by the speed of sound, because the sound is a direct distance between you and the aeroplane. The direct distance is the speed of sound, the distance between the aeroplane and you. You multiply that time by the speed of sound, what will give you the distance, how far the aeroplane is from you. So you are really doing simple algebra. You are looking for two unknowns, the speed of the aeroplane and the distance of the aeroplane from you. And you have two variables that you can determine the angle at which the aeroplane travel from in front of you to the point where it makes maximum sound. If you wanted to understand the physics why we're doing that, you simply have the physics of two vectors. The vector of the speed of the aeroplane and the other vector is the speed of sound. Because the sound is generated behind the aeroplane and it travels from there in a sphere or circles. And when it hits your ears as maximum, that vector will be a composite of two vectors. The speed of the aeroplane traveling in one direction and the speed of sound traveling in your direction.